This is an introduction to generating confidence intervals using the Texas Instrument TI-83 or TI-84 calculator. For this demonstration, I'm going to use the TI-84 emulator. And also notice that I'm using the Confidence Intervals Review to illustrate how to calculate some of these values and answer some of the related questions. So this particular problem says find the margin of error when constructing a confidence interval for a population mean given that the confidence level is 90%, given the standard deviation is 3.2 for the sample, and the sample size is 10. Notice the actual mean has not been given. That will be an interesting thing that we have to consider when we do this particular problem. So to get a confidence interval on our calculator, we use the stat button, and most of our intervals and hypothesis testing problems are going to be accessed through the test menu, so I left arrow to test. And notice there is no t-interval, which I typically use for a confidence interval for means, but if I arrow down to the next option after 7, I see that option 8 is t-interval, so I could either hit the number 8 or hit enter at this point. I'll hit the number 8, and it gives me the option of actually using data or using statistics to do this confidence interval. Well, since no data was given, only the statistics summarizing a sample of data, then I will use stats. Now again, they don't give me a mean because the only thing that would determine the error for a confidence interval is the standard deviation of the sampling distribution, the sample size, and the confidence level. So I can put anything I'd like for the mean. I will put 10. The standard deviation we see is 3.2. The sample size is 10. The confidence level is 90%. And I calculate. And notice that the middle of the interval, the point estimate, is irrelevant for this problem. I really want to know how far is it from the center of this interval to the extremes, and that will give me my error. Now if I hit any button here, it's going to erase these values, so you may want to write down on paper what these values are, but it's also valuable to understand that these values are always saved in the calculator under VARs. So if I hit VARs and then go to number 5, which is statistics, and then go to the test menu, left arrow gets me there faster. I still don't see what I'm looking for. I'm really looking for the lower and upper bounds for this interval, but if you up arrow, there they are. So I can say upper, which is alpha I, or just hit enter. And then if I subtract from the upper, the VARs, number 5, left arrow twice, up arrow to the lower option, the upper on that interval minus the lower will give me the range for the interval. And if I divide that by 2, that is the error for my confidence interval. And you'll notice the error for this particular problem was 1.85. Now, I may also ask questions like, what would the point estimate for this interval be? Rather than hunting upper and lower down again, I could simply say second enter, and change that minus to a plus. And if I take the sum of upper and lower and divide by 2, notice that will give me my center of the interval. And so I found a way to generate confidence intervals and use the upper and lower bounds to answer questions associated with that interval. Let's look at the second question. Construct a confidence interval for a population mean of automobile emissions at a 95% confidence level using a sample of 7 cars that have a mean of 0.12 and a standard deviation of 0.04. Now remember, we discussed that sampling distributions for very low sample sizes will have quite a bit of error associated with them. So that is why we're using t-intervals. The t-interval, as you go smaller and smaller sample sizes, becomes higher at the tails and lower in the center, and therefore accounts for that larger error. And so I will actually do, once again, stat, left arrow test. I now remember the t-interval is at number 8, so I don't have to arrow down. I'm once again using stats. This time they do give me the mean of 0.12. The standard deviation is 0.04, and the sample size was only 7. And this time the confidence level is 0.95. This is associated with automobile emissions, a little more of a concern to our population. Therefore, we want that confidence level to be higher. And then I calculate. And notice once again, my upper is 0.15699, the lower is 0.08301. And so I have my confidence interval, which best matches up with answer C. And once again, if I wanted to get the, say, the error associated with that confidence interval, because I've done it previously, I can second, enter, change the upper plus the lower to upper minus lower, and then divide that result by 2. That is the error associated with that confidence interval. And of course, you could calculate that error directly simply by saying, what is your t-value associated with the number of standard deviations from the mean you would like to use for that confidence level of 95%. And you would also like to use the actual standard deviation of the sampling distribution. So just as an exercise, I will use inverse t to find the t statistic that separates the 95% region from the 5% region, keeping in mind that if it's a 5% region outside the confidence interval, there's only 2.5% on each tail. So I'm going to do inverse t of 0.975, and then for t you must put in a degrees of freedom. Since the sample size was 7, I put in 6, and that will be the t-value, or the number of standard deviations from the mean that I would like to use to create my confidence interval, and therefore that would be a part of my error calculation. And if I multiply that by the standard deviation of my sampling distribution, which I recall is the standard deviation of the sample, divided by the square root of my sample size, which is 7, keeping in mind that that was my first calculation for the error, and now my second calculation is identical. So it gives you 2 different ways to calculate errors for confidence intervals. Let's do problem number 3. Determine the required sample size needed to be a 95% confident that a political poll is accurate within 0.03 if the actual population percentage given that the estimate is p hat is 0.87 or 87%. So if I have a sample from a unknown sample size that gives me a ratio of 87 over 100, I want to know how large would my sample have to be in order for me to be 3% within 3% accuracy. So you'll notice, as I've shown here, error is always, for a proportion, a z-score rather than a t-score. The number of standard deviations from the mean you would like associated with a 95% confidence level times the standard deviation of the sampling distribution. If you don't know what your actual population proportion is, and you don't here because you're actually trying to estimate it, you'd actually use the sample proportion for your p. So in this case we'll use p hat instead of p. So my calculation first of all would be, how do I obtain my z-score? Remember, z-scores are second and then the VAERS, which is dister, inverse norm, which is number 3. And now for this particular area, I'm going to have to find the area